It says it's recording. That's good. Okay. So here I go. So this is our third session for the Tuna 10S transmitter. The agenda is here. Welcome to Bob Fontana, if he's online. Bob Fontana is the guy that wrote the article in QST in December that inspired me to talk to Phil about having this project. I sent off an email to Bob a week or so ago, and he responded happily, and we exchanged a few emails. He said that he wanted to monitor what we were doing, see our progress or regress, whatever it is. And so I suggested that he join DIY Radio, which he did. And so he also sent me an updated sketch. So we have updated software that gives us a couple more options on the rate of changing the frequency. So anyway, we don't need that now. Nobody's got a transmitter fully functional except Phil at this point. So anyway, we have ordered everything and we've received some things. We ordered from Tata Electronics for most of the electronic components like resistors and capacitors and transistors and things. We ordered toroids from Kits and Parts, W8DIZ back in Florida. Phil and I have ordered things from him many times over the years. Phil ordered the PCBs from JLC PCB in China. This is the second version of the boards. And then we also ordered a number of things from eBay. At this point, perhaps Phil can tell me what's the latest on his end.
Well, the way it stands, all our Tata stuff is just left Louisville, Kentucky on the 2nd, 2 days ago. And it's due at my place in Sacramento on Monday. That's most of the loose pieces and parts. And then our printed circuit board shipped via Global Direct air freight. And Global Direct decided to take their plane off today. So I don't quite know when it's going to land in the great US and how it gets forwarded, but I would imagine we're looking at it again next week until we have the boards. And so at this point, I think the only thing we're missing, you've got the nanos, right, Bob?
I have the nanos and the toroids. That's all I've received.
So we've still got the synthesizer and I've got the display. So it's just basically the synthesizers that are still due. And the cables? The cables
are still due also.
They're still due. So we're probably 2/3 of the way there. And I would think next week we'll pretty much have everything in hand. I even spooled out all the wire to wind your toroids. In fact, here's 20 coils of wire, each of which is 6 turns of 15 inches each. You need about half of that to wind your toroids. So we're in pretty good shape. As I said,
you're not talking about our bodies and our minds though, right?
What's that?
You're not talking about our bodies and our minds being in good shape, right?
No, I was on a golf course yesterday and I'm convinced my body is in no shape.
Okay.
And I imagine Saturday I'll verify that assessment.
Yeah.
But aside from that, I think we're in pretty good shape. You know, this QRP stuff got me kind of stimulated, and I have been piddling around with a QRP SWR/watt meter. And in fact, let me show this to you. This is far from a pretty picture, but it uses a small little current transformer torrid and then 2 voltage transformers. And believe it or not, the first try with this, I tried it on 40 meters and 20 meters. And this constitutes a 10 dB coupler. And then there's a 20 dB attenuator on each side of it. And the SWR in this thing, believe it or not, measured 1.08 to 1. And it tracked perfectly at 10 watts and it tracked perfectly at 1 watt. So I'm going to piddle around with this and maybe use another little Arduino and some of these 8307 logarithmic amplifiers. And I think I can come up with a nice little compact QRP watt meter that's digital and accurate. We'll see how that plays out.
It's great. There's a bridge on there.
There is no bridge. It's a Brune network that samples voltage and current. Of course, you add those vectorially. So you get forward and reflected. Pretty directional.
Okay. Very good.
That pretty much constitutes my presentation for the evening. We'll let the master take over from here.
Well, are there any questions for Phil? Nothing.
Silence is golden.
Nothing heard. Okay, I'll go back.
Phil, I have a question for you. KI6RT. What core did you use for your SWR meter? Was it like a 43 material?
FT3743s.
Okay, all right, perfect, thanks.
Okay. I'll launch back to my my presentation then. Okay. Just to recap what we did last time, on uploading the software, you basically install the Arduino IDE. If anybody hasn't done that, well, I will help you with it. Just let us know. Once you've got the IDE, you copy the sketch, the software, to a folder of the same name. And when you double click the sketch in that folder, it will run the IDE. This is assuming you have a Windows system. Then you have to install the SI5351 and SSD 1306 libraries that we got from Adafruit, the company. And then under the tools, you make sure you're set up for the Arduino Nano, the ATmega 328P, and for the programmer, the Arduino ISP. Then you connect the Mini B USB cable between the Nano and your PC, and the operating system, Windows, will detect or set up a port, activate a port for you. You select that port within the Arduino IDE, and then all you should have to do is to click the upload arrow button, and it should upload the software to the Nano.
Can we ask at this point, Bob, how many people have successfully gotten that far?
Good idea. I don't know how many people can chime in and how we would do that, but is there anybody that needs help? If so, please send messages to us.
If I remember in the last meeting, you indicated that those instructions were going to be sent. Have they been sent or stored someplace that we can access and download?
They were sent as messages to anybody who belonged to the DIY radio group. They were also stored as a PDF file up in the files area of DIY radio.
Okay, thank you.
Also, Marty had a Google Drive that I was using last time we met and tried it while we were live, and it was successful.
Okay, good.
So could you guys just raise your hands how many of you successfully have installed this? 1, 2, 3, 4. 4, okay. Thank you.
So just to make sure I understand, which is usually I don't, we can do all the loading to our Windows machine, but we're waiting for the Arduino and cable to actually upload it to the Arduino itself.
Right.
Okay.
You can compile the software, but you can't upload it until you have a Nano cabled to your PC.
Great.
Confirm that, Bob. I was following the directions and got to step 14, which is plug the Nano in, and we don't have that. And so that's as far as we can go at this point, correct?
That's right. You need hardware to run
Yep.
software.
I had a question. If I do have an Arduino and I'd like to use it for something else, how difficult is it to clean out what I programmed and use it for some other purpose?
Very easy. You just compile and upload the different software.
Okay, so they override each other. All
Yeah.
right.
Exactly. Yeah.
And Bob, can you tell me the PDF location again?
Did you join DIY Radio at group?
Yes, I did. Yes, I joined. I have not had a chance to spend much time there yet.
Okay. Well, you just need to log in and then go to the files area.
Okay.
And you'll see Tuna 10S, and within that, you should be able to find the file.
Okay, we'll take a look. Thank you.
Alrighty. Yeah, I'll go back to my presentation then. This is a photograph of 3 Arduinos.
I don't think you're sharing your screen.
Oh, okay. Good idea. I should do that. Yeah. Blah, blah, blah. Right. This, okay. Are you seeing it now?
Yeah.
There we are.
Okay, good. I'm not thrilled with the interface, but anyway, here are 3 Arduinos. On the left-hand side is the package you will receive as part of the kit. Inside of that package is a Nano plus 3 sets of pins that need to be soldered to the Nano. It's in an anti-static packet with that caution sign on the top that's warning you that you better be authorized and you better not destroy this Nano by having 1 trillion electrons on your hands. So you need to make sure you aren't statically charged when you handle the Nano. But when you open that package, you will take the pins, the headers, and line them up on both sides of the Nano, and then solder 30 different pins to the Nano. The Nano that's in the middle of the screen here is one that's had the pins soldered to it, and it's standing up.
Bob, you might mention to them that they can put those pins in backwards too. They want to make sure that USB connector's on top.
Yeah, there's probably more than one way you can mess it up. Yeah. So we will get to that point. Before you get your Nanos, we'll give you instructions on how to do that. On the right-hand side, there's another Nano. This Nano is upside down. It is a dead Nano. You can tell that because it's on its back and it has its feet up in the air. So, that particular Nano, I plugged into a prototyping board that I wired, and I could have sworn I double checked the wiring and everything was good. I plugged it into the board, and then when I applied power, I heard a snap noise. No crackle and pop, just snap. And then the thing was deader than a doornail. So I guess I'll use that as a doornail from here on out. Anyway, that's the way it is when you're doing home brewing stuff. Now and then things break. So, here's another screen similar. Let me get that out of the way. All right. It's the same 3 nanos. The package on the left, you can see better now. You'll see that there are rows of pins here on a header that needs to get soldered to one side of the Nano, and then there's another set that gets soldered to the other side of the Nano. There's also a 6-pin set of headers that would be soldered at the end of the Nano, but I don't even bother to do that since we don't use that. So you can just set those aside. Anyway, in the middle is a Nano ready to plug into our transmitter. And I won't talk much about that at this point. I'll talk more in a further slide. On the right-hand side is the dead Nano. And since it's lying on its back, you can see what's underneath, what's under the top. And there's an IC on the left-hand side that is a voltage regulator to be able to supply 5 volts and 3.3 volts available for circuitry. On the right-hand side is another IC, a rectangular IC here. And what that is the serial interface. It talks between the microcontroller and the USB cable. So that's a serial interface for the USB connections. Any questions at this point? If not, I'll move to the next slide. So here is the transmitter. In the current state of my transmitter, I've soldered some of the parts. I haven't finished it. You can see the Nano at the bottom here with the USB cable connected. It's not connected to a computer at this point, but that's what the USB cable will look like. Yours, I think, will be black instead of white, but it'll work the same way. The USB cable will supply power to the whole transmitter while we're uploading to the Nano. But afterwards, after we're done programming the Nano, great. They wanted to time me out here. I had to say, give me more time. Oh, great. Zoom wants me to pay for more time.
Well, it's got a countdown. You've got 9 minutes and 30 seconds or so.
Okay, I'll rush through it then.
Maybe if necessary, you can disconnect and restart the new meeting.
I don't know.
Hey, watch out! I'm a shareholder. Just kidding.
Okay, I'm gonna move ahead. It seems they're letting me go ahead.
That stock's done pretty well. I wouldn't apologize for it.
Anyway, after you program the Nano, you can power it from a different power source by connecting batteries to the DC jack in the lower right-hand side of the board. And here it is running and showing the frequency on the display. Now, since I've got the boo-boo board, Phil's made some changes to fix this, and I have some extra wires there to reverse signal to move forward. Okay, at this point, I want to show you this picture of the Nano. I assume everybody can see this picture of a Nano, right?
Mhm.
Very,
Okay,
well, we cannot read it, but we can see it.
okay. Down the left-hand side are 15 pins. Down the right-hand side are 15 pins. The big diamond in the middle is the actual microcontroller, the processor that runs the software. We're going to ignore this business up at the top. We could program through there, or we can program through the USB at the bottom. In this section right here are 4 LEDs. There's one for transmit, one for receive, and one for power. And then this one says L at the top of it. It's an LED that's connected to pin D13. And through an instruction, you can turn that LED on and off through software. Right here in the middle is a reset button. When you press that button, it will reboot the software. This little gizmo is a 16 megahertz crystal. And that's about it. I'm not going to talk more about that.
There's a lot of stuff on a little tiny plate.
Oh yeah. The Arduino Nano, the Italian version, is about 20 bucks. We bought the Chinese knockoffs for less than $3. That makes me feel bad. But I'm thinking that what we're doing is expanding the market for the Arduino people. The Nano is a 30-pin module. Some of the pins have multiple purposes, but there are 13 digital pins that have binary or on-off states of 0 or 5 volts. There's also 8 analog pins that can be used to measure voltages in the range of 0 to 5 volts. There's also 2 interrupt pins, and we will use those. And there's also multiple interfaces that I'll say a little bit more about here in another slide. You supply power to the Nano with 7 to 12 volts, and that regulator on the bottom of the Nano supplies 5 volts to one pin and 3.3 volts to another pin that can be used for other circuitry. And in this transmitter design, we use the 5 volts to power other devices in the transmitter. And like I said, you can program it either way with the USB or with that ICSP connector, that 6-pin connector that was at the top of the Nano picture there. The brains of the whole outfit is the AT Mega 328P microcontroller. It's an 8-bit, 32-pin processor. On board, it has 32K of non-volatile flash memory, including 2K devoted to a bootloader. The bootloader on the Nano is like a little operating system, so that when power is applied to the Nano, the bootloader runs. The bootloader then runs our particular sketch, our compiled sketch. Non-volatile means that when the power is turned off, it retains its memory. There's also 2K of volatile static random access memory, and that memory gets erased when we turn the power off. And that's where the variables get stored. There's also 1K of electrically erasable, programmable read-only memory, which we don't use in this application. And there are 3 serial interfaces. There's a universal synchronous, asynchronous receiver transmitter. Now that is used with that chip on the bottom of the Nano to communicate with the USB connector. There's also an I2C interface, which we use to talk to both the display and the synchronous clock generator. The I2C is also called IIC and TWI. There's like 3 names for the same protocol. And then there's an SPI interface that we won't use. On the microcontroller, there's also 6 pulse width modulation channels and an analog digital converter. And the microcontroller has a repertoire of 131 instructions. So that's basically my presentation for tonight. The next session will be 2 weeks from now, where we'll tell you what's the state of the kits at this point. And I plan to talk a bit more about how we use the OLED display and the clock generator using that I2C interface. And we might change the agenda before then, but that's basically it for me tonight. That was pretty fast run because I'm afraid that Zoom will cut me off. So. Are there any questions?
Quick question. I see the 7 to 12 volt power supply requirement. I saw you had an 8-cell battery pack off to the side. That's usually ends up more than 12 volts. So does it tolerate a little bit more than 12 volts?
I don't know. This
It'll
company,
handle up to 15 pretty handily.
I'm using lithium batteries, so I'm getting 11 something. I'm getting less
Okay.
than 12 volts when it's fully charged.
Got you. Thank you.
Okay.
Actually, that FET is good through, I think it's 100-volt FET, so you're not going to cause too much trouble there. 15, 16 volts, I think it'd hum along very handily.
But it probably burns off in heat, regulate voltage.
No, the regulator just powers up the microprocessor, the display, and the clock. That's all that the regulator does. The FET is powered directly off the bus, and it won't cause you any grief. The only concern may be the bias being set properly so that the idle current's correct.
I have a question. This may be somewhat outside of what we are working on, but what's the difference between Arduino Uno and Nano?
One's the size of a postage card, and one's the size of 2 stamps.
Okay, that I can see.
They both have the same microcontroller on them, but from there on it's different. There's more, there's more, sockets in the Uno, but it's functionally the same.
I think the I/O structure is identical, Bob. I think they've got the same number of functions, the same pin identification.
Yeah, I have a message here saying we're going to shut down in 1 minute, less than a minute, so 40 seconds. So
I'll talk fast. So are you implying that whatever Uno can do, whatever Nano can do, Uno can also?
yeah, it's the same microcontroller. Yeah, the same software will run on both of them.
But physically, they connect to different pins differently.
Yes.
Good night, guys.
Go to the Arduino.cc site and see pictures of the two of them and set them side by side and see the specifications